Deep beneath the streets of Oakland, California, something incredible is happening every single day. Two massive pieces of Earth's crust are slowly pushing against each other with tremendous force. They barely move, but every year the pressure grows stronger, storing energy like a giant spring being squeezed tighter and tighter. The worrying part is that this pressure has been building for more than 150 years. Scientists say the geological clock for this fault has already run out. This is the story of the Hayward Fault, one of the most dangerous fault lines in the United States, and the powerful computer simulations that are giving experts their clearest look yet at what could happen when the next major earthquake finally strikes. The Hayward Fault is not hidden in a remote mountain range or far away from civilization. Instead, it stretches for about 74 miles directly through California's East Bay. It passes beneath busy neighborhoods, schools, hospitals, highways, shopping areas, and important transportation routes. Cities like Oakland, Berkeley, Hayward, Fremont, and several others sit directly on or very close to this fault. More than 2 million people live or work along its path. That alone makes it one of the most dangerous earthquake zones in North America. The last major earthquake on the Hayward Fault happened in 1868. Scientists estimate it reached around magnitude 7. Even though California had far fewer people at that time, the earthquake still caused widespread destruction. Buildings collapsed, roads were damaged, and the shaking was felt all the way to San Francisco. But today's California is very different. The population has grown enormously. Cities are packed with homes, offices, bridges, rail systems, power lines, water pipes, and communication networks. A similar earthquake today would affect millions of lives. One reason scientists are especially concerned is the fault's history. Research shows that major earthquakes on the Hayward Fault have happened roughly every 140 years on average. It has now been more than 150 years since the last major rupture. While earthquakes cannot be predicted with an exact date or time, scientists agree that the fault has gone longer than its average cycle without releasing its built-up energy. According to the United States Geological Survey, there is about a 1 in 3 chance that the Hayward Fault alone could produce a magnitude 6.7 or larger earthquake within the next 30 years. But the picture becomes even more serious when nearby faults are included. The Hayward Fault connects with the Rogers Creek Fault to the north. Together, these connected faults greatly increase the chances of a major earthquake somewhere in the system. Scientists estimate there is roughly a 72% chance of a large earthquake occurring in this regional fault system by the year 2043. That is no longer a distant possibility. For many people living in the Bay Area today, it could happen within their lifetime. For years, scientists understood that a large earthquake would be dangerous, but they could not fully predict exactly how different neighborhoods would experience the shaking. The Bay Area has very complicated geology. Some areas sit on hard bedrock. Others are built on soft soil, loose sediment, or deep underground basins. Each type of ground reacts differently during an earthquake. Until recently, computers simply were not powerful enough to model all of these complex conditions in great detail. That has now changed. Researchers from Lawrence Livermore National Laboratory and Lawrence Berkeley National Laboratory use some of the world's most powerful supercomputers to perform 50 different simulations of a magnitude 7 earthquake on the Hayward Fault. Instead of creating just one prediction, they tested many different possibilities. They changed where the rupture started. They adjusted how quickly it spread. They measured how seismic waves traveled through different types of ground. The result was one of the most detailed earthquake studies ever completed for the Bay Area. One discovery stood out above all the others. Not every neighborhood would shake the same way. In fact, two places only a few miles apart could experience completely different levels of shaking. The Eastern Hills, including communities like Orinda and Moraga, sit on softer layers of underground rock. These softer materials actually make earthquake waves stronger. Scientists found that shaking in these areas could be up to 50% more powerful than in nearby locations built on solid bedrock. That difference could determine whether a building remains standing or suffers severe damage. Another area that caught researchers' attention was Livermore Valley. Unlike the Eastern Hills, the biggest concern there is not necessarily stronger shaking, it is longer shaking. Livermore sits inside a geological basin. When earthquake waves enter the basin, they bounce back and forth instead of passing through quickly. Imagine shouting inside a large cave where the sound keeps echoing. Something similar happens with earthquake waves underground. Instead of lasting only a short time, shaking in Livermore could continue for more than 2 minutes during a major earthquake. That may not sound very long, but during an earthquake, 2 full minutes feels like an eternity. Long-lasting shaking places extra stress on buildings, bridges, pipelines, warehouses, and other important infrastructure. Oakland and Berkeley face another unique danger. Because they sit so close to the fault itself, they could experience something called directivity. This happens when the fault breaks and the energy moves rapidly in one direction. Instead of spreading evenly, a powerful burst of energy races ahead, hitting communities directly in its path. These concentrated pulses can be especially damaging to tall buildings because they create strong, sudden movements. Scientists found that certain locations near the fault could experience ground forces approaching the strength of Earth's own gravity. Buildings that were not specifically designed for this kind of motion could face much greater risk. Meanwhile, parts of western San Francisco rest on harder bedrock. Hard rock allows earthquake waves to move through more quickly without becoming greatly amplified. Because of this, some western neighborhoods may experience 20 to 50% less shaking compared to the highest risk areas closer to the Hayward Fault. That does not mean these places are safe. A major earthquake would still be extremely serious. But local geology gives them an important advantage. Understanding why this happens is actually quite simple. Think about dropping a pebble into a calm pond. Ripples spread outward in every direction. Earthquakes create similar waves that travel through the ground. Hard rock allows those waves to move quickly and lose energy. Soft soil slows them down. As the waves slow, they become taller and more powerful, much like ocean waves growing larger as they approach a beach. Because the Bay Area contains many different types of underground material, every community experiences earthquakes differently. The new simulations help scientists identify exactly where the strongest shaking is most likely to happen. That information is incredibly valuable. It allows engineers to improve building designs. Skyscrapers in Oakland and Berkeley can be strengthened to better handle sudden pulses of energy. Homes built on hillsides can receive extra protection against landslides. New buildings in Livermore can be designed to withstand longer periods of shaking. Transportation systems also benefit from these findings. Bridges, highways, tunnels, and the Bay Area Rapid Transit System, known as BART, can be upgraded in locations where simulations show the greatest risk. Improving these critical systems now could help emergency crews respond faster after a future earthquake. Scientists also emphasize that ordinary people have an important role to play. Simple preparations can make a real difference. Heavy bookshelves, televisions, and cabinets should be secured so they cannot fall. Water heaters should be properly fastened. Emergency kits with food, water, flashlights, batteries, medicines, and first aid supplies should be ready for at least 3 days. Earthquake early warning systems and smartphone alerts can sometimes provide several seconds of advance notice before strong shaking arrives. That may not seem like much time, but even a few seconds can allow people to protect themselves by dropping to the ground, taking cover under sturdy furniture, and holding on until the shaking stops. The science behind earthquake research continues to improve every year. Researchers are now applying similar computer models to other major faults, including California's famous San Andreas Fault. As computers become even more powerful and underground mapping becomes more detailed, scientists hope to better understand how future earthquakes may behave. While no technology can stop an earthquake from happening, better knowledge helps communities prepare before disaster strikes. The Hayward Fault may be growing more dangerous, but knowledge gives us a chance to prepare before disaster strikes. If you found this video informative, don't forget to like, subscribe, and turn on notifications for more fascinating stories about science, nature, and the powerful forces shaping our world.